Yesterday's class we were discuss about the reactivity of hydrogens and reactivity of oxygen with G16 elements. Whenever the G16 elements can react with hydrogen to form the hydrides having formula EH2. Examples of that hydrides can seen, that is H2O, H2SE, H2S, H2T, etc. Then second point, that is reactivity towards oxygens. Whenever G16 elements can react with oxygen to form the oxides, that is two types of oxides, EO2 and EO3, dioxides and trioxides. So in this class, learn the next point of chemical property, reactivity towards halogens. Reactivity towards halogen. What is the reactivity of G16 elements with halogens or towards halogens? We know what is the halogens, the elements which are placed in 17th group of periodic table called as halogens, which are very reactive. The elements fluorine, chlorine, bromine, iodine, etc. All these elements contain 7 electrons in last cell. It requires only 1 electron for the completion of octet. Therefore, all these halogens are very reactive and highly negative elements. So, the reactivity of G60 elements with halogens. First, the G16 elements. The G16 elements reacts with halogens to form large number of compounds. Whenever the G16 elements can react with halogens to form the large number of compounds of halides, such as EX6, EX4, EX2, etc. Whenever the G60 elements can react with halogens, then it forms the compounds of halides, such as EX5, EX4, EX2, where E means to what? All G60 elements. E means to what? All G60 elements. Which are G60 elements? It is oxygen, sulfur, selenium, tellurium or polonium. But generally, the sulfur, selenium, tellurium can react with halogen to form the halides. First, EX6 hexahalides, EX4 tetrahalides and EX2 dihalides. So these types of halides of compounds are formed when G60 elements can react with the halogens. First is the hexahalides. Hexahalides example SF6, then SEF6, TEF6. Sulfur hexafluoride, selenium hexafluoride, tellurium hexafluorides are formed formed by direct combination are formed by direct combination. The hexahalides SF6, SEF6, TEF6 are formed by direct combination of G16 with halogens of 6. These are colorless. All the hexahalides are colorless gases. Colorless gases having sp3d2 hybridization, and possess, all these are the colorless gases having sp3d hybridization and possess octahedral structure. See again, whenever the G60 elements can react with 6 halogens, then it forms the hexahalides. For example, SF6, SEF6, TEF6 are formed by the direct combinations. All these are the colorless, does not having any color, and these are the gases, colorless gases having sp3d2 hybridization and possess the octahedral structure. The stability order, the stability of halide decreases as order of what's fluorides, chlorides, bromides, and iodides. This indicates in halogens, fluorines are much reactive. Chlorines are less than that of fluorine, and bromines are less than that of chlorine and fluorines. But iodides, that is iodines, are very less reactive than that of all these elements. So these are the hexahalides. Then tetrahalides. How to form the tetrahalides? Whenever the 4 halogens, that may be chlorine, fluorine, bromine, iodines, can react with the element of G16, then forms the tetrahalides. SF4, SEF4, then TEF4. Sulfur tetrafluoride, selenium tetrafluoride, tellurium tetrafluoride are the tetrahalides having sp3 hybridization. This one which can link with the single bond sp3 hybridizations and trigonal bipyramidal geometry. Trigonal bipyramidal geometry with one equatorial position of lone pair. See again, tetrahalides. How to form the tetrahalides? When 4 halogens can combine with one element of G16 to form the tetrahalides. sulfur tetrafluoride, selenium tetrafluoride, thallium tetrafluorides, all these tetrafluorides or tetrahalides having the sp3 hybridization. This what can link with a single bond. Then which are trigonal bipyramidal structures. Trigonal structures with bipyramidal structure or geometry having one equatorial position of the lone pair of the electrons. So this is the hexahalides, then tetrahalides. Then see the third one, dihalides. Dihalides of G60. Dihalides. Whenever G16 elements can combine with two halogen atoms to form the dihalides, for example, sulfur dichloride, selenium dichloride, tellurium dichloride, etc. All these are the examples of dihalides can combine with G16 elements. Sulfur dichloride, selenium dichloride, tellurium dichlorides having all these havings sp3 hybridization, sp3 hybridization. All these dihalides can possess the sp3 hybridization and possess tetrahedral structure. Tetrahedral structure with two equatorial position, two equatorial positions occupied by lone pairs. What dihalides? All the dihalides having sp3 hybridization and tetrahedral structure with two equatorial position occupied by lone pair. So these are the dihalides. Last one is the monohalides. Is to what? 1:1. One G60 element and one halogen can combine together to form the monohalides. All that monohalides are diametric in nature. Monohalides are diametric in nature. Monohalides are diametric in nature. For examples of monohalides, how to form the monohalides? These are the diametric in nature. Example: S2F2, Se2F2, or Te2F2, fluorine, chlorine, bromine, serine. All these monohalides, 1:1 ratio, same. That is called as monohalides, which are the diametric in nature, undergoes disproportionation, because which are the diametric in nature, so shows the disproportionation. So this is the reactivity of halogens with G16 elements. Let's see the next point, fifth, reactivity of G16 elements with metals. Reactivity with metals. Fifth point, reactivity with metals. You know metal, sodium, magnesium, aluminium, number of metals. Those elements which have tendency to lose electrons are called as metals. What is the action of G60 elements with metals? The elements of G16, that is oxygen, sulfur, selenium, tellurium, polonium, all these, the elements of G16 reacts with metals to form corresponding oxides or corresponding compounds, to form corresponding compounds depending upon their valencies. Suppose first element of G16, that is oxygen, O2. When this oxygen can react with magnesium, Mg, then it forms the 2MgO, magnesium oxide. Likewise that this oxygen can react with sodium to form the sodium oxide, reacts with aluminum to form the aluminum oxide. Instead, any metal can react with oxygen to form the corresponding oxides. Then second element of G16, that is sulfur, can react with copper. Copper is a metal. Copper reacts with sulfur to form the copper sulfide. Zinc reacts with sulfur to form the zinc sulfide. Then magnesium can react with selenium. Then it forms the magnesium selenides. Likewise that G16 elements can react with different metals to form the corresponding compounds. Suppose oxygen reacts with any metal to form the oxides, magnesium, sodium, aluminium, any oxide, zinc oxide. Then sulfur can react with metal to form the copper sulfide. Zinc reacts with sulfur, zinc sulfide. Lead reacts with sulfur, lead sulfide. Selenium can react with any metal to form the corresponding metal selenides. Suppose magnesium can react with selenium to form the magnesium selenides. So this is the reactivity with metals of G16 elements. After that, next point, 6th, G16 elements can show the allotropic forms. Allotropy of G16. Allotropy of G16 elements. We know all the G60 elements, which are that oxygen, sulfur, selenium, tellurium and polonium. All G16 elements can show allotropic forms. Allotropy. How? The oxygen shows 2 allotropy. Or allotropous. Oxygen shows 2 allotropic forms, which are that first one is the O2, dioxygen, and second one is the O3, ozone. In G60 element, oxygen shows 2 allotropic forms. First is the O2, that is dioxygen, and second allotropous form is the ozone. So oxygen shows 2 allotropic forms. Then sulfur shows number of allotropic forms. Sulfur can show the number of allotropies, such as first rhombic sulfur, rhombic sulfur. Second, monoclinic sulfur. Monoclinic sulfur. Third, plastic sulfur. Fourth, milk of sulfur. Milk of sulfur. Colloidal sulfur. Colloidal sulfur. This sulfur can show the number of allotropic forms. First, rhombic sulfur is also called as alpha sulfur. Rhombic sulfur is called as alpha sulfur. Second, monoclinic sulfur is called as beta sulfur. Third, plastic sulfur. Fourth, milk of sulfur. Then colloidal sulfur. Likewise, that number of sulfur forms can be obtained in the allotropics. Third, after the oxygen sulfur, selenium. Selenium shows. Selenium is the third element that selenium can shows two forms, two allotropic forms. Allotropy. First one is the red and second one is the grey. Selenium can show two allotropic forms. First is the red selenium and third one is the grey. Red is the non-metallic. Red is the non-metallic and grey is the metallic selenium allotropic forms. Then after that, tellurium shows two allotropic forms. Two allotropy. First is the crystalline tellurium and second one is the amorphous tellurium. Tellurium can show two allotropic forms. First is crystalline and second one is the amorphous. And last one, fifth, polonium shows two allotropy. Polonium shows two allotropy, that is alpha and beta. Polonium can show only two allotropy, that is alpha and beta. Both are metallic in nature. Both alpha and beta are the metallic in nature. So all G16 element can show the allotropy. Oxygen shows two, dioxygen, ozone. Then sulfur shows number of allotropic, rhombic, monoclinic, plastic, milk of, colloidal sulfur. Selenium can show two allotropic form, red selenium and grey selenium. Red is the non-metallic and grey is the metallic. Then tellurium can show two allotropes, crystalline and amorphous. And last, polonium can show two, alpha and beta. Both are the metallic in nature. So these are the allotrope of G16 elements. Okay.